In this example, we're going to practice going backwards. So in other words, an inverse normal problem. So again, the distribution of exam scores on a certain exam is normal with a mean of 80 and a standard deviation of 5. Suppose people who score in the top 5% are given special recognition. What score puts someone in the top 5%? So again, I'm going to draw a picture of our exam scores, normally distributed, centered at 80, with a spread of 5. And now I'm going to draw in the top 5%. I don't know what the score is, but I do know that this area is 5%. So this is where the top 5% would be. And the question is, what's that score? So when I know the area, but what I'm looking for is the value on the x-axis. So in other words, the value of the test score that cuts off the top 5% from the bottom 95%, that's an inverse normal problem. So again, we're going to do this with technology. So we would come to an online calculator, and we're going to go to the inverse normal calculator. The inverse normal calculator allows you to enter the area. So the area I'm interested in is 0.05. And again, this is my picture that I drew, so I know that what I've done is correct. If sometimes you might be looking for the bottom 5% or a middle ground, but this picture, that's why I always recommend drawing the picture first. Okay, the mean is going to be 80, and the standard deviation is going to be 5. And we can see that it's already been calculated for us. That score is 81.6. So let's go ahead and record that. So this comes out to be 81.6. Now, we know that on an exam, you can't score 0.6 of a point, so probably we would answer this about 82 points. One of the things that I pointed out here is that this is exactly the same as asking you to find the value of the 95th percentile, because what is the value of the 95th percentile? It's the score that cuts off the bottom 95% from the top 5%. So another way of asking this question would have been, find the value of the 95th percentile.